So guys, my ML project idea is to predict movie box office revenue with revenue success with data science and machine learning techniques. This is main idea is to turning creativity into predictability. So the thing is, can we predict a movie's box office success before it even hits theater? So in the movie industry, success is famously unpredictable. Big budgets, famous actors, huge directors, sometimes even those who don't guarantee a hit. At the same time, small movies with almost no budget sometimes surprise everyone and become blockbusters. So, why does this matter? Because being able to predict a movie's success could save studios millions of dollars. It could help streaming platforms decide what to buy. Uh, it could help theaters plan what to show and when. In short, prediction could change the business of entertainment. Today, I'll walk you through how we approached this problem using machine learning techniques in a way that even non-technical audience can understand. Goals of the research, goals of our project outcomes. So the goal of our project was simple but ambitious, to predict a movie's box office revenue before it releases, based only on information available early like its genre, budget, cast, and release date. We wanted to answer what factors really drive movie success. Can we build models that predict box office performance early enough to make a difference? So, who benefits from this? The studios for better budget planning, marketers for smarter promotional strategies, streaming platforms for better content acquisitions, theaters for more profitable scheduling. If we could find patterns early, every major player in entertainment ecosystem could make more informed, smarter decisions. Now, coming into the data sources and preparation. So we started with raw data from a popular open source platform called the TMDB API, the movie database. So it includes information like movie budgets, revenues, genre and language, popularity metrics, cast and directors. At first, the data was messy. There were missing values, codes instead of readable names, and lots of extra noise. So, after cleaning, missing information was filled. Genre and languages were mapped into readable forms. New features were created like a release season and franchise status, which turned out to be very useful for prediction. This gave us much richer, cleaner dataset to work with. The up left image is of the raw data with all noise and uh, other information, and the right down image is the clear and final data after pre-processing. Now, coming into the interesting findings which we have found from the data, let's talk about what we found and which methods really mattered. So, visual data insights. So, before modeling, we learned a few key things just by looking at the data. The things are action, adventure, and thriller movies dominated all of the other genre movies as expected. Franchises and superhero movies make the most money out of the other franchises and superheroes. English language films dominated globally, but non-English films are growing thanks to the platforms like Netflix and other things. And popularity trends are rising fast, fueled by streaming on social media. These trends help guide how we build our models. Now, coming to the model implementations and model methods. The first one which I have implemented is K-means clustering. So, what is K-means clustering actually? A model that groups similar movies together without knowing anything beforehand. So, how it works? It looks at things like budget, revenue, and popularity and automatically sorts movies into natural clusters based on how close they are in the data. So, we grouped movies into clusters without labels, purely based on their features like budget, revenue, and popularity. We found three natural movie groups: the low budget independent films, mid range performers, blockbusters. This clustering helps segment movies early, even without knowing their box office outcome yet. Coming to association rule mining. What is it actually? A method to find relationships between things that often happen together. So how does this work? If a movie is in English or produced in USA, there's a high chance it follows other similar patterns we find if this then that rules from the data. So we explored relationships like language and country. One interesting pattern was US produced movies in English dominate massively, which is not a surprise and as expected. But smaller countries or languages or other languages showed patterns too, helping identify growing markets. So implementation of naive-Bayes algorithm, what it actually is. A simple model that predicts outcomes based on basic probabilities. And how does it works? It assumes all features work independently and makes a prediction based on which outcome is most likely, like guessing weather based on humidity. So tested a simple probability based models while fast, naive struggled with complex financial relationships. It achieved about 79% accuracy, good but not strong enough for serious financial predictions, but not on the best fit for movie financial data. And the importance was quick models. This was a quick model, but struggles with complex patterns. Decision trees. So what it is? A series of decisions arranged like a flowchart, like a game of 20 questions. So how does it works? The model asks yes or no questions. Is the budget high? Yeah. Or is it an action movie or not? And leads down a path to final prediction. So I've built a rule-based trees to classify movie success. They were very easy to explain. That if a movie has a high budget and summer release, it's likely a hit. So, but without careful tuning, they tended to overfit, memorizing training data instead of generalizing. Still a great for visualization. Coming to logistic regression, what it actually is a method that predicts chances of success or failure, either 0 or a 1. So, how it works actually? It draws a boundary line based on the data. One side of the line is successful movie, and the other side of the line is not successful movie. So, logistic regression performed very strongly, which gave outcome about 94% accuracy. This was the fast, simple, and great at drawing clean decision boundaries. Worked very well for predicting movie success versus failure. It became one of our most reliable early models. Now for the SVMs, a model that tries to separate different groups of movies with the widest possible gap. So how does it work? It finds the best dividing line between the categories so that groups are as far apart as possible. So SVM model created very sharp separations between movie categories. So linear SVM reached about 98% of accuracy. It was one of our most accurate models, drawing very clean boundaries between blockbuster movies and rest. Coming to the last models, ensemble models, in which I have applied random forest, XGBoost, AdaBoost. So what are these actually? It was a teamwork between lots of small models to make much better prediction. So how does it work? Instead of relying on one decision tree, we build hundreds of random forests or carefully fix mistakes step by step, XGBoost and AdaBoost. So then we combine their answers to get a stronger, more accurate result. So finally, we combine multiple models together on an approach called ensemble learning. So the learning results were fantastic, as expected. The random forest gave a very high accuracy with 95%. AdaBoost gave a strong but little sensitive to noise data. So it gave accuracy up to 93%. And the last one, the XGBoost, which was the best model of overall, giving the 99% of accuracy. If a studio or streaming platform wants the most accurate prediction possible, XGBoost would be the ideal choice. Coming to the conclusion. So, what does all this mean without a technical jargon? So success is multidimensional. It's not just budget. Success comes from smart storytelling, good timing, genre appeal, and audience buzz. So bigger isn't always better. Having a huge budget doesn't guarantee a hit. Some modest budget movies perform far better than expensive ones. Early predictions is powerful. If you can predict success early, studios can allocate budgets better, marketers can focus their promotions smarter, streaming services can pick winners before competitors, investors can lower their financial risks, and future potential is exciting. Imagine combining these models with real-time data, Twitter buzz, YouTube trailer reviews, early critic scores. The system could dynamically adjust predictions, almost like having a financial advisors for movies. And coming to the final thought, movies will always be an art form, but with the right data, we can make smarter art. Thank you.